Hi everyone, my name is Alawi Assaggaf. I am a database engineer at 8x8. I have been working the past 6 years for Fuse, and Fuse was acquired by 8x8 earlier this year. Both Fuse and 8x8 are specialized in VoIP and unified communication services for businesses. In today's presentation, I'm going to be discussing MySQL production configuration with ProxySQL and Orchestrator. This presentation is divided into three sections. In the beginning, I'll start with an overview, a statement or a general overview of what the problem that I'm trying to solve in this presentation, and then I'll move on with a quick overview of each technology I will be working with, starting with Orchestrator and then ProxySQL. Throughout the overview, I'll go into some configuration options and some decisions on why specific configurations were used. In the second part of this presentation will be a quick discussion about different use case scenarios based on the configuration we have done in the first half, and explaining how it's going to be working in these different use case scenarios. Finally, there will be a quick demo so you have a taste of how this works in real life. Okay, so the main problem I was having is, or the main problem I'm trying to solve is decoupling from applications. Usually, whenever there is a change or an upgrade that needs to be done on the databases, we need to plan with application and dev teams. Depending in the scenario, this could be very complicated or very simple, but in many cases you will need to plan with the dev teams for a downtime, for a release schedule. Maybe some changes are required in the application side as well. So I'm trying to decouple from this so that the database changes can be independent and doesn't affect the applications directly. Give us a lot of freedom and flexibility in terms of implementing and deploying changes in the database section. This helps, of course, with making changes smooth and simple. Another problem I was trying to solve, or at least I'm aiming to address in this presentation, is having no specialized hosts. There are different kinds of setup where you have obviously the master and the slaves. Sometimes the master is configured differently than the slave because the master maybe is having higher rights and the application is doing more writes than reads, or vice versa, where you have the slaves with more horsepower than the master. Maybe you have different specialized slaves for specific applications that would handle special loads, so you will configure them differently than the others. For me, this introduces different kinds of problems, challenges with the management and even with the configuration when it comes to configuration management. So having no specialized hosts, unique hosts, instead make everything unified was one of the goals that I was trying to address in these designs. Of course, read scalability and high availability are obvious requirements. On top of all of that, I wanted all of these features in a simplified setup. Might be asking too much, but we'll see. And I have seen different ways ProxySQL and Orchestrator configured with console. In this presentation, I'm not going to be using console. Based on the point mentioned earlier, I'm trying to simplify the setup, so trying to make it with less moving parts and less components as possible. Nothing wrong with using console. It's just that this is the way I decided to make this this setup. Obviously, console could be introduced in the design I'll be presenting today. Both Orchestrator and ProxySQL provides rich features and various ways of tuning and configuring it. I will be focusing on relevant configurations, relevant aspects of each technology. It's not going to be a dive in. I will reference some links that you can read if you wanted to explore more into some of these options. Load balancers will be discussed briefly in this presentation, but the options will not be discussed. It's assumed there are so many different load balancer solutions. Whatever load balancer you choose, whatever is your favorite, is fine as long as it's implemented one way or the other. We will get to that point later on. Okay, so to visualize what I'm trying to get to, so imagine this simple setup where you have a master and 3 slaves. I want to be able to start pushing changes on the different nodes one by one without causing any downtime or problems in the application. So no one application is dependent in any of these slaves. I can take them down anytime, push the update. The red means updates have been pushed. Now all the red are the same configuration or receive the same update. The master is still there. I want to be able to dispose of the master without worrying. And if I want, I can refactor the master and the old master and make it join the cluster again. The reason I'm calling them nodes is to kind of illustrate that they are all identical. None of them is configured any way differently than the others. All right, so Orchestrator, for those who don't know, Orchestrator is simply put, it's a high availability solution that is topology aware, and it runs as a service, and it provides CLI and web interface for management as well as API. The setup in a high level, I'm going to discuss each point in the next slides, but in a high level, Orchestrator is configured in this presentation with SQLite backend using Pseudo-GTID. I'll be going over the master and intermediate master briefly, the configuration for master and intermediate master recovery. I'll discuss how I'm getting the cluster name and the DC, as I will be using that to prevent cross DC failover. High availability setup for Orchestrator itself. Okay, basic configuration. This is the top part here is the grant you need for the Orchestrator user. There's a special grant for Pseudo-GTID that will be discussed in the next slide, but you need it if you are using Pseudo-GTID, which I recommend. In Orchestrator configuration, these are the two options to set the user and the password. I'm just using the default for now, but make sure you change that in your production environment. So Pseudo-GTID, briefly, it's a method that Orchestrator implemented to inject the binary logs with an ID that helps it to track and decide which coordinates the slave should be pointing to for the new master, whether during a failover or if you are moving slaves around. The injection would happen on the master, replicate through the relay logs, and gets into the slave's binary log because we need to enable the binary logs as we will see in a few slides. This slave is now ready to become the master if a failover happens, or if we are making it an intermediate master. This way, using this hints, Orchestrator is able to figure out where the slave stopped and match that on different nodes during a promotion or a change of master. So, as I mentioned, you need to have binary logs enabled for sure in each slave, because each slave is promotable. In the basic setup, of course, there are options to make to specify the promotion rule if you want specific hosts not promotable. You need to log the slave updates because you want to make sure, especially for the ones that you want to be promotable, because if it becomes the master, if there is another node that would become a slave of the newly promoted host, you want to make sure that it receives the updates it was missing in case it was delayed, or if the position it will be pointing at is different than it was catching up at the master. To enable SQLite backend is really basic options. There isn't anything crazy about it. This link here has a sample for the SQLite configuration, orchestrator configuration. These are the two options you need. This is the reason I went with SQLite. It's very basic setup. It comes embedded with the orchestrator. Nothing, no more setup. You don't have to do anything in the back end. Sometimes you can have MySQL as the back end as well. If you feel that your setup is big, the number of clusters and the topologies you are managing is more than SQLite can manage, of course you can go with MySQL. In my case, SQLite have been good enough. Again, here are the sample configuration if you need to look into it further. Okay, so getting the alias name. This is very important because it does simplify the configuration of Orchestrator. It simplifies your automation if you define a cluster name. There are very different ways. There are many different ways that you can get the alias name, including creating a table with rows specifying the cluster name, the data center name, and many different configuration. I have seen that done many times, and if you do a quick Google, you'll find people specifying the cluster name in different ways. Personally, I prefer in general to know what the function of the host just by looking at its host name. And as an example, let's say I have this host which is named MySQL application 1 DC101. So I know this is a MySQL node for this specific application located at this DC, and this is number 1 out of X numbers of nodes. Using this example, it's divided into these sections: the database technology, the cluster name, the DC number, and the host number. Based on that, I can use these queries, which is defined in Orchestrator's configuration. You pass this query in Orchestrator configuration to pick up my alias and my data center. It's the same query, I'm just specifying which part, depending if it's the cluster for the second and the DC for the third. Again, there are different ways to do this. Okay, so to enable master and intermediate master recovery, it's really basic. You need to make sure this option is set up so that whenever there's a promotion, you want the new master to execute slave reset all. Sorry, reset slave all, so that it doesn't pick up the new master when it comes back online, if it ever does, because Orchestrator will kick it out of the topology, promote a new master. You want complete isolation to avoid any kind of problems. This is an important option where you want to avoid a flicker of multiple failovers if there's any problem, network or otherwise. You want to make sure that Orchestrator doesn't keep executing failovers one after the other. So this is the default, which is 1 hour. You can change it to whatever fits your requirements. one of the neat features in Orchestrator is that you can specify which clusters you want for master failover and intermediate master failover. You can actually specify and separate the two options. Sorry. And here comes the importance of, or an example of the importance of a cluster name. So you can specify which clusters that you are monitoring through Orchestrator that would be promoted. A star means all the clusters that are defined in Orchestrator go ahead and execute failover whenever there's a master failure. Of course, you can specify the clusters as it's done as an example here, where you specify the names of the cluster that you want to execute a promotion, whether it's a master or intermediate master. So if you clear this, no intermediate master failover will happen. Again, one of the things that I really like about Orchestrator is the hooks, because this gives you a lot of flexibility in terms of automation or customization when it comes to failover. If there are specific pieces or process that you want to enforce, the hooks allow you to, at different stages of the failover, to push your commands and enforce your rules and automations. Some of the important hooks, in my opinion, there are more than that you can find in the documentation, but the pre-failover process that once Orchestrator detects failover, it will call anything defined in the pre-failover process before executing the failover itself. Watch out though, if your pre-failover script is taking time, failover will not happen until the pre-failover process is done. So make sure it's a quick script or quick command, or run it in the background. Post-master failover process happens after a master failover completes. Post-intermediate master failover happens after an intermediate master failover finishes. Post-failover processes, it doesn't distinguish whether it's a master failover or intermediate master failover. So if there's a specific thing you need to push regardless of the failover, we will use this one. If you want a specific one for master or intermediate master, you will use the previous two. And post and successful failover, if the failover fails, it doesn't succeed, there's a specific hook for that. You can also make use of tokens and variables that will substitute values within the hooks processes. So here's just an example, just to illustrate it. Let's say pre-failover, you want to push a note in the logs, or you want to notify the on-call, or you want to push it into a Slack channel, whatever it is. You can use tokens, so failure type and failure cluster will be mentioned. And again, here, a good use case for naming the clusters. Another example, let's say you want specific commands to run after an intermediate master failover. For example, let's say you have your intermediate masters as writable nodes for whatever reason, and you can execute a command and saying, well, after you do the intermediate master failover, make the successor host, the new promoted node, to writable. Maybe you have some other commands, you can just provide it there and pass some of one of the tokens or the variables as an option. Here's the link if you want to look into hooks further. Some other options that are worth checking is fail master promotion on log minutes, or fail master promotion if SQL thread not up to date. This is if you want promotion not to happen in these cases, or delay it. And the last one, which is really important, is if you have specific hosts that shouldn't be promoted. Maybe you have a host that's a backup, for specialized for backup, or delayed hosts as a mean of disaster recovery. using replication delay. Whatever is the use case you have, you can specify it here. In my case, as I said, I don't want any specialized hosts, so I'm keeping it simple. Prevent cross DC or cross regional failover. You have both options. You can, as we defined our DC earlier, you can also have a query to define the region. However you define your global presence in terms of region and DC, you can have that flexibility. Just for this presentation, let's say I only care about DC. So for example, if your region is US and the UK, those are your regions, and you want to fail over anything that's in the US, but you could also go even in more details and say, nope, I want only to fail over San Francisco or Boston, for example. So if my master is in Boston, do not promote anything from San Francisco. So however you define your presence, you have that ability to control. So prevent cross DC failover. Earlier, I had a query to define as DC1, DC2, so anything, if the master is DC1, DC2 will not be promoted. High availability, it's really important to have Orchestrator set up with high availability, because you don't want a failure to happen while Orchestrator is not reachable or not functioning, or any issues that may cause it. Not to be able to detect the failure, otherwise what's the point? Raft is an option. There are different ways of configuring high availability. You can use MySQL high availability if you use MySQL as a backend. The link here is specifically for Raft, but if you look into the documentation, you will find different ways of implementing high availability for Orchestrator. This is specifically for using Raft. I'm using SQLite. You can use MySQL, but as a standalone backend, so no replication, and you will still be able to use Raft as well. Straightforward options: enable Raft, specify the directory, bind address, the port for the Raft, and you need to specify the Orchestrator nodes that are part of the Raft cluster. Now, it's important to have it in different DCs availability zones, or however your data centers are divided. Just in case there's a network problem, at least you have 2 or 4 if you are going with 5 Orchestrator cluster that are still functioning and able to execute failovers. Alright, so that was Orchestrator. Moving forward with ProxySQL. Again, for those who don't know ProxySQL, it's a layer 7 proxy. I have seen it being confused as a load balancer. It could function as a load balancer, but it's not really meant to be specifically a load balancer. As described in the website, it's a workload management service. It provides many features and different ways of tuning the workload to fit your use case and to fit your needs. I have been using ProxySQL for over 2 years, and I'm happy with it. I'm really happy with it. You can divide some of the important features is that you can define host groups that you will define your query rules based on it to route the queries based on those rules and specify to the host groups. The obvious one is to divide the host groups between writers and readers, and route them based on if they are select to the readers, if they are not to the writers. One of the features I like about ProxySQL is that you can push the changes on the fly. You don't need to reload or restart. You can push it into the runtime configuration, and it applies right away. And it provides clustering options. ProxySQL clustering. You can cluster different ProxySQL nodes into a cluster, and that opens up different possibilities. So, discussing the benefits of ProxySQL maybe needs its own presentation, but for the sake of the time, I'm picking up three benefits. So for developers, the connect, you can make, using ProxySQL, you can make them connect to a single URL, and you don't care about what's happening in the back end in the database side. ProxySQL divides the queries or reroute the queries based on the query rules the DBA sets up. Query caching, there's an interesting story with query caching. It might be not an obvious benefit for ProxySQL, but I have seen use cases where some applications will be hitting the database over and over several times within the second against exactly the same table, which has minimal changes. It rarely gets changed, so it keeps doing the round trip for exactly the same data. You can do query caching in ProxySQL and save the data and define the refresh rate, and during that time the information is right there, and I have seen significant improvement in the application side because of that. So that's why it's in the top, in the not top, but in the 3 points I thought to include. For DBAs, the ProxySQL has its own monitoring capabilities. It's implemented. You don't need to add your own scripts or ways of confirming the health of the MySQL nodes. It's compatible with automatic failovers, as we will see soon. Obviously, the scalability options it provides. Again, those are just a few points I thought to include for this presentation. The setup of ProxySQL in this presentation, or at least the points I will be discussing in the coming up slides, setting up the interfaces, enabling monitoring, using the read-only check to define the host groups or which host goes to which host group, using PT heartbeat for lag monitoring. During the preparation for this presentation, I used a recent version of ProxySQL, run into an interesting problem, which made me use a scheduler to fix the problem. So I'll be discussing that, adding a scheduler to work around it. Disabling the writer is also a reader. There is a way you can enable that or disable it based on your needs. And finally, setting up the ProxySQL cluster. Okay, so the interface, the default setting is the port is 6033. It's just, I think, a way of making sure you don't conflict with an existing ProxySQL on the same node, I assume. But you can configure it into the default MySQL. That's what I have been using, and it made sense to me at least. I'm dividing it into centralized and decentralized. The centralized is basically a hub in the middle where application will connect to the ProxySQL. ProxySQL connects to MySQL. Decentralized, ProxySQL is set up in the application side on the same host. In some cases, I needed to make the application believe it's talking to MySQL. So for simplicity, I provided exactly the same socket as MySQL, and the application, minimal changes in the application side. It talks to ProxySQL as if it's talking to MySQL. Nothing complicated here. Those are default options. Monitoring is enabled by default. You have the username and password defined as monitor by default. Again, make sure to change that in your production environment. There are many different monitoring options and variables that you can check with this query. This is the link to the documentation about monitoring if you want to fine-tune how frequently and how often it checks and some options regarding the replication lag. The user doesn't need any wild permissions, usage and replication client to check for the replication lag. Okay, so using the read-only check, ProxySQL provides a table that, based on the information you provide, would decide each MySQL host belongs to which host group. The table is MySQL replication host groups. You define the writer host group and the reader host group, and what check to use to define which the host go to which host group. And comment just for easy reading. So I'm defining my writer host group as 0 and my reader host group as 1, and the check I'm using is read only. So ProxySQL will check if the host has read only on or off. If it's off, then it's a writer. If it's on, then it's a reader. I mentioned earlier that with ProxySQL you can load your configuration to the runtime without having to restart or reload. This is the command that you will use. There are different options that you can use for a check, including NLDB read-only, super read-only, a combination, and or. So you can read about this if you think you need one of them specifically for your use case. Configuring BT heartbeat, it's a basic configuration, the same as any BT heartbeat. You create a schema, you create the table, you guarantee the privileges, or user will be BT heartbeat in this case. In ProxySQL, you need to add the user. ProxySQL, any user that connects through ProxySQL will need to exist in ProxySQL as well. So you define the user, BT heartbeat, password, and you want the default host group to be 0. As I mentioned earlier, 0 is the writer, and because BT heartbeat writes to its own table, you need it to be pointing to the writer. Specifying the default host group, make sure that the connection goes to that default unless it matches a query rule. The second option you need to set in ProxySQL is to enable Percona heartbeat. There's a specific variable for that, and as soon as you provide the schema and the table, ProxySQL figures out that this is how you want to check the replication lag. These are the configuration I used for the BT heartbeat. I got it from a Percona blog that you can reference. It has really interesting argument about setting up ProxySQL with BT heartbeat. It was written by David and Ivan, and they discuss a problem that I found was resolved in newer version for ProxySQL regarding the replication lag being enforced even for the master, for the writer nodes, which caused problems. I didn't see that problem anymore, but I found a different issue. After a failover, sometimes ProxySQL gets confused, and apparently the reason was because there are more than one entry in the BT heartbeat. The old master has its own entry still there. I haven't looked into it deeper. I came across it as I was preparing for the presentation. This solved the problem, whether it's the best solution or not, but basically I'm checking if there is more than one entry in Percona heartbeat. If there is, delete anything that's not the current master server ID, because this will go to the writer, because the way query rules is defined, or I defined it, is that if there is a select, it will go to the reader. By default, BT heartbeat anyways is going to the writer, so this is going to the master. The server ID will be the writer server ID, although it might be best to save the server ID. And anyways, I'm not going to think about this now, but you could pick up the server ID and make sure you put it here, because this will anyways, let's not get into this. now. So basically, there is a link here to an issue. There had been a change in the way ProxySQL queries Percona heartbeat table using min instead of max, if I'm not mistaken. So that changed the behavior, and this is one way to solve it. Just keep an eye for it, make sure you test it, and implement a solution like this if needed. If you need a scheduler, like in this example, you just insert into a scheduler table, which you can specify the script you need to run and how often. I'm running it every second. Maybe it's aggressive, maybe it's not. You can specify if it's active or not. All right. Clustering. So there are three variables you need to change in ProxySQL. First one is the admin cluster username, admin cluster password, as well as the admin credentials. By default, you will have admin, which what you will use to log into ProxySQL. So when you have MySQL user admin password admin to log into ProxySQL, you need to also add these because the remote ProxySQL will connect to ProxySQL admin using this username and password. So these credentials need to be defined so that when a connection comes from the remote ProxySQL to sync its information or does the check, you need to give it that access. Once these configurations are done, there's a ProxySQL servers table that you can insert which nodes you want to sync with. Pay attention to the port 6032, which is the ProxySQL admin port, not the MySQL port. Wait, based on the documentation, it's not used yet. I haven't seen any mention that have been used, so don't worry about it. A comment is just for your own reference and easy reading. This is straightforward from the documentation. Basically, so far only these tables are synced, so any changes on this table, if you add a new server or a new user or query rules, etc., will be synced with whatever node is defined in the cluster on the ProxySQL server list. There are two links here, one from the documentation, one from the blog. When clustering was enabled in ProxySQL, you can reference them for details. Anything outside of these tables will not be synced, but I think this is what matters for now at least. There haven't been anything more than this that needed to be changed, in my end at least. So for this specific implementation, read only need to be the default in my.cnf, so that whenever a server comes up, it comes up as a read only. It makes sure that we don't get into a split brain. If a node comes up that's registered in ProxySQL, ProxySQL sees it as up. If it's a write or if write is enabled, we have a potential problem of split brain and potentially many other problems. All right, so now we have configured the ProxySQL and Orchestrator. Now, how would this be set up? How does this solve our problem from earlier? So you probably remember this design I showed earlier in the presentation. With the configuration that had been made in the previous slides, now our setup looks like this. So we have 3 orchestrator nodes in the left. Each has its own SQLite, and they are all connected through Raft. Each orchestrator node is monitoring the whole topology. In the middle, we have our MySQL cluster. In the right, we have 2 ProxySQL nodes to avoid a single point of failure. They are configured to sync within each other, so an update one will go to the other. You could probably disregard the clustering point for a simple setup of two ProxySQL node if you depend in a configuration management tool that pushes the changes to all nodes. It's here to illustrate the idea. As I mentioned in the beginning, a load balancer here is mainly to make sure we don't have a single point of failure in ProxySQL. So put whatever load balancer you prefer, whether it's HA proxy or a load balancer from your favorite cloud provider, whatever it is, because we only care about avoiding a single point of failure. This could even be keep alive D, for example, where you're flipping the VIP based on the health of the ProxySQL node, and the applications will only connect to that point, and the whole point of simplifying the setup and decoupling from the application. In a Zoom, okay, yeah, so going through the changes, whether doing a graceful failover or killing MySQL, I don't recommend that, but we can kick out the old master. Orchestrator takes care of that. ProxySQL picks up a new node with read only off, figures out this is the writer node now, redirect the connections for writes. Orchestrator have already moved the slaves from here, from node 1 to node 3, and using Pseudo-GTID, this process is really simple. Any alerts or hooks would have been executed. Human intervention goes into node 1, reconfigure it, and rejoins it into the cluster. Application are running fine. No changes needed in the application side. This is all done with Orchestrator and ProxySQL managing it in the background. A zoom in view just in the ProxySQL side. Basically, this is host group 0 based on the read only off and read only on. The synchronization here is in 2 ways, and if you want, you could add more. This is the part about the scalability. You can add more slaves as you go, and as soon as ProxySQL picks up that node, either with manual insert into the ProxySQL server or through a configuration management tool, it will automatically be assigned as read-only, because if you remember, we have read-only as our default. Now, there is a case when if during a failover the old master comes back online. We will discuss that further in the demo. Okay, so for decentralized ProxySQL, let's say you have an application that is complicated to change, and you still want its own, it still needs its own ProxySQL, or sorry, MySQL node on the slave itself, or sorry, on the application side itself. You can basically configure ProxySQL to be in the node using exactly the same configurations we had before. The only difference would be if it needs the MySQL socket. You remember that from earlier in the interface slide. You can provide a socket that mimics MySQL, and the application will pick it up normally. Same use case, same failover process. If this guy goes down, the other one will be picked up. The only problem with this is that you have more, depending on how many of decentralized setup you have, or decentralized implementation you need to push. You have more nodes to configure and more nodes to manage. So you will need to find a way to manage each ProxySQL node. It might be a configuration management problem, but this is something to consider. Again, zoom in. as you can see, it's exactly the same concept as earlier, except here we have ProxySQL on each node. What I call a hybrid ProxySQL is basically combining the previous two solutions. This potentially could solve the problem we had in the second case for local ProxySQL, where we can configure the local ProxySQL to pull the configuration and the users and the servers from our centralized nodes. Let's say we have some application that would use the same cluster that still need its local MySQL, or for whatever reason ProxySQL needs to be in the application side to avoid extra hops. Whatever the case is, there is a way to configure it this way, and in that case you only have two nodes to manage instead of X amount of ProxySQL nodes. Another possibility is, and this is theoretical, I haven't played with it yet, but I can't help it but think this could be a very good use case for Kubernetes. If you want the application to connect to MySQL instead of worrying about the whole stateful problem, push ProxySQL and make it pull the configuration from existing nodes that's defined in your pod configuration. Something I hope I can play with sometime very soon, but it would use exactly the same concept with a one-way sync, because ProxySQL clustering allows both options, two-way sync or one-way sync, depends on how you define your ProxySQL server lists. All right, so this is brings us to the end of the presentation, where I'll be demoing the first use case, just a very simplified setup, just to illustrate how this works in real life. All right, so as you can see, we have the orchestrator on the left here, and as we mentioned earlier about defining the DCs, you can see them defined here, DC1, DC2, based on the naming here. That's the query I was using. I realized I made the mistake of not including the cluster as well, app1 for example, and this might be a good way of demonstrating why this is a bad idea, because right now the cluster name is the master name. As we will see in a bit, this will not default our demo, but it would at least illustrate why it's very important to have a cluster name defined. I was hoping to demonstrate intermediate master failover as well, but given the short time left, I'll only be doing a master failover. Would have just moved these slaves around, put it for DC2, put them together as slaves, and make this intermediate master. So just showing you how simple it is to deal with Orchestrator. Of course, be extra careful when it's production. Okay, so we have ProxySQL in the top here, and this is the current acting master in the bottom. So if I check the runtime MySQL servers, it's important to check the runtime to know the status of the current MySQL nodes. So I only defined these, as I said, I'm only doing this side of DC1 of the implementation, but it's the same concept if I move further. And let's kill the active master. All right, I'm on the right host. Yep. Okay. All right. There we go. It started the failover, and ProxySQL is showing node 1 as shunned. Sometimes Orchestrator is Orchestrator web interface sometimes is slow. As you can see here, it may still take some time to rebuild the topology graph. So don't worry if you don't see it right away. So DC101 have been kicked out. There is nothing underneath it. And now we have another cluster. As you can see, the cluster name has changed. And this causes a lot of problems if you are doing automations. So if I go to the dashboard, I have two clusters, one solo and my cluster here, which received the promotion. Now DC2 is the new master, and if I start MySQL again here, DC1 will show online. It's timed out automatically. It's still shunned in ProxySQL. I have been running continuous select on the back. No connection is going to node 1. It's running every second. And there are no connections running on the back end. The reason is, if I go to MySQL, heartbeat, from, if you can see, the timestamp is not changing, and this way the host, ProxySQL detects that this node is behind, and I will not include it in here. So I need to recover this host manually and make it rejoin the cluster again. If you remember earlier, I said you need to acknowledge any recovery. You will find it in recovery, and you go here to acknowledge it to allow for another failover to happen. The last thing I wanted to mention is DC2 was not promoted because I have a rule that says do not allow cross DC failover. Another thing I wanted to mention, in the same page where you acknowledge, it does give you the breakdown of the recovery steps. You did see that it took some time to refresh the page, the web interface. However, here it gives you exactly the breakdown of the recovery. And you can see the second it started or detected the problem and when everything actually completed. So the process actually took a second. It's just that the web interface takes some time to rebuild. And here you can see exactly each step. Remember that I mentioned earlier about the hooks. See, it goes in that order. Running one pre-failover process hooks, which is the default. It explains to you exactly what it did. This is what it ran, and that's why it's important to make sure it's quick. It doesn't even give you how long it took to execute the pre-failover process and then the actual recovery. So if this took long time, it will delay the recovery process. It tells you exactly what type of recovery and what it did, regrouping, and you can read through this to understand exactly what decision it took. And this is again something really great that Orchestrator provides. Okay, this takes me to the end of the presentation. Thank you so much for your time. I hope you find that valuable and it added some benefits. And I would like to hear your feedback. I want to take the opportunity to thank the teams behind Orchestrator as well as ProxySQL for the great products and great contribution to the open source community. Also, I want to thank Percona for their continuous support of the open source community and for holding this presentation And thank you so much.